supersonic aircraft were developed in the second half of the 20th century. But even today, interest in such aircraft has not faded, and engineers are working tirelessly to set another speed record. In today's video, we'll be telling you all about an American startup that's creating an aircraft capable of surpassing even such a monster as the Lockheed SR-72. Hermeus is a startup based in Atlanta, Georgia, specializing in the development of commercial hypersonic airliners. In 2018, people from SpaceX and Blue Origin, led by AJ Piplica, CEO, have set out to realize their dream of bringing new space to aviation. Previously, the term new space has been firmly established as a designation for aerospace companies operating on a commercial basis to provide mankind with cheap access to space. But it's unlikely that anyone would be against it if, in parallel with this, a team were to appear whose planes could transport you in a breeze across the Atlantic in just 90 minutes. Meet the plane Quarter Horse. Like its namesake, the American Quarter Horse, this aircraft will be ideal for covering distances quickly. The startup announced the development of a hypersonic unmanned aircraft in 2019, and by August of 2020, it signed a $1.5 million contract with the U.S. Air Force, which is considering the Quarter Horse as an aircraft that will, in the future, be able to join the U.S. presidential fleet and serve as Air Force One. In 2021, NASA also became interested in Hermeus, deciding to collaborate with the startup to create a unique device with a speed of Mach 5 and a range of 4,600 miles. The agency has repeatedly worked on hypersonic vehicles before. One of NASA's first steps in this direction was the X-15, a manned rocket plane that reached Mach 6.7 in 1967. And just a little later, the agency introduced the X-43, an experimental hypersonic aircraft that broke the Mach 9.6 threshold. Now, 17 years later after the debut of the X-43, the Quarter Horse project is a great opportunity for NASA to try its hand at developing hypersonic passenger aircraft. Agency specialists will evaluate the device's technological maturity and regularly exchange experience with the Hermeus team in order to achieve the most effective result in the process of creating this futuristic aircraft. The technical solutions developed by the partnership teams will be applied and tested by the Hermeus specialists on the GE J8521 jet engine, which has become the basis for the new TBCC turbine-based combined cycle engine in the first series of devices. The same J85s were used on Northrop F-5 jets and proved to be a reliable and durable solution for American aviation. As the startup grew, it received 6 more of these engines, which served as the logistical base for the study and creation of its own patented TBCC Chimera. Less than 2 years after the announcement of ambitious plans to develop a 20-seat hypersonic quarter horse, Hermeus engineers greatly upset the skeptics by successfully completing development tests of key subscale elements for their propulsion system in Mach 5 conditions. The startup then proceeded to build a larger testbed to evaluate the scale flight version of the TBCC engine. The Hermeus concept is founded on the use of a TBCC engine incorporating a ramjet, rather than a supersonic combustion ramjet or scramjet. Initial testing of a small-scale prototype in 2019-2020 was based on a production 290-pound thrust TJ100 turbojet engine, supplied by Czech high-speed turbine manufacturer PBS. Combined cycle elements include a pre-cooler of their own design and a ramjet engine. The turbojet is designed to operate from a standing start up to Mach 3.3, while the ramjet operates in a transitional range from about Mach 2.8 to over Mach 3, and then beyond to set the apparatus in motion up to Mach 5. The team soon began static testing at Hermeus's first facility, Site 27, a converted shipping container. The facility owes its name to its location, next to the decommissioned Runway 27 at DeKalb Petrie Airport. It took only 33 days to prepare, and a mere 4 weeks to complete 50 test runs with the GE J8521 engine. During the test campaign, the engineers accelerated the turbojet to Mach 3.2 using a pre-cooler, after which they tuned the prototype to the ramjet mode exclusively, accelerating it to the Mach 4 to 5 range. Now the main question was how to get the engine to switch from turbojet, Mach 0 to 3, to ramjet, Mach 3 to 5. Additionally, integrated propulsion testing was done to see whether the design could insulate the turbojet from the heat of the ramjet during high-speed cruise at an inlet temperature of about 1800 degrees Fahrenheit. In interviews, the head of Hermeus, AJ Piplica, clarified that their TBCC engine had a mass flow rate 10 times greater than that of the test prototype, adding that the team developed a pressure burner and nozzle for its rear end, as well as a ram burner and a nozzle for the back of it, along with a bypass system, inlet, and pre-cooler. In the summer of 2022, the startup displayed Chimera's work, which launched an afterburner at the Hermeus test site in Atlanta. This was the final step in the static test campaign at sea level, proving that the team could run their patented engine at full throttle on the ground. But, since their plane would fly at an altitude of more than 80,000 feet, it would have to face extremely hot temperatures, so the specialists weren't going to stop there, starting their next round of tests at the Turbomachinery Laboratory of the University of Notre Dame. This facility allowed them to test their creation via simulating flight-like pressures and temperatures by directly connecting to their supply of heated air. In November of 2022, Hermeus demonstrated the transition from a turbojet to a ramjet engine in a new video showing Chimera's work, having spent only 21 months and $18 million on the entire development cycle. The transition from one mode to another works in the following manner. At low speeds, the Chimera operates in a turbojet mode, like any jet aircraft. But as the temperature and speed of the incoming air both increase, the turbojets reach their limits. This happens at about Mach 2. This is where the Chimera comes in handy with a pre-cooler that lowers the temperature of the air entering the turbojet, allowing you to squeeze much more performance out of the turbojet before switching to a ramjet engine. At around Mach 3, the Chimera begins to bypass the incoming air around the turbojet, and the ramjet takes full control. A ramjet literally rams the incoming air at high pressure to create compression. The fuel is mixed with this compressed air and ignited for thrust. In the field of hypersonics, the Hermeus TBCC engine is truly unique. By creating a full-range hypersonic air-breathing engine that doesn't require a rocket to accelerate, the startup is setting the stage for an operational hypersonic aircraft that can be reused. An additional advantage to this engine design is, among other things, its adaptability to existing transport infrastructure. Quarter-horse aircraft and other Hermeus projects can be used at ordinary airports. Speaking of unique technologies, one cannot fail to mention the fact that about 15% of the engine was printed on a 3D printer, which significantly accelerated its production. Moreover, the engineers purchased Sapphire printers and large-format Sapphire XC printers from Bello 3D to produce parts not only for the engine, but for the entire aircraft as a whole. Both models have been calibrated to work with Inconel 718 superalloy. It's also worth noting that Bello 3D additive metal manufacturing technology has become widespread in the hypersonic and space industries precisely because of its ability to create complex, critical parts that engineers need, without compromising design, quality, or performance. Since the aircraft will be unmanned, its flight deck was designed from scratch to support off-grid standalone operations in austere environments. There is room for a pilot, payload operator, 4 mission analysts, and several places for observers. A dedicated high-performance computing center, HPCC, has an isolated climate control zone to protect all mission-critical flight equipment. This HPCC supports dual redundant cloud-based computing and power architecture in accordance with DoD RPA ConOps requirements, and uses advanced rapid prototyping, artificial intelligence, and machine learning technologies. Additionally, the flight deck was built to DoD secure room standards, allowing for turnkey open storage, video conferencing, and operations. But most importantly, all this good stuff fits in an unmarked intermodal container, due to which the control center can be deployed anywhere in the world. It's too early to talk about the specific dimensions of the quarter horse and its final cost, but by 2021, data emerged that the aircraft would be about 40 feet long and have a wingspan of 10 feet. How true this is, really, we'll be able to verify in 2024. It was then that Hermeus intended to conduct its first flight test. In 2025, the company plans to introduce a medium cargo version, and in 2029, to give the world its first commercial passenger quarter horse. When it comes to technology, many companies often use the term game changer. However, hypersonic aircraft and their engines are truly game-changing and could revolutionize the way we travel, just as cars did. And we'll be happily watching, keeping you up to date with the latest in the industry. Do you think Hermeus will be able to perform its first commercial hypersonic flight with passengers before 2030? Share your opinion in the comments below. And if you enjoyed the video, please leave a like, subscribe to the channel, and hit that notification bell for more content like today's. Thanks for watching, and we'll see you in the next one.